Greetings and welcome to Train Signal. You're watching an understanding of Exchange 2013 architecture and server roles. So before you get too nervous about the word architecture, what exactly do we mean when we say Exchange architecture? Exchange architecture revolves around how Exchange works. Basically, how email flows through and into mailboxes, and the underlying processes that make that happen. So no need to get too nervous just yet when we say architecture. We're really just talking about how Exchange works. So let's walk through this together. Remember, all email and the calendaring items and the contacts and the tasks, all of that information, it has to go somewhere. And eventually you can see it through your Outlook, but ultimately it has to sit somewhere first before your Outlook or your ActiveSync device or whatever it is that you use to connect into your Exchange environment. Before it reaches out and touches that information, it's sitting somewhere. So where is it sitting? Well, it's sitting in a database. And so Exchange needs a database as well as an engine to help manage that database. Exchange uses the Extensible Storage Engine, ESE, also known as JetBlue, as its database engine. And as far as the database, in the end, the database is a single EDB file. And there's one per database. Now you can have more than one database for an Exchange server. You might be wondering why you might do that, but when you look at an EDB file and you see that it continues to grow and grow and grow as email comes into the Exchange server, then you realize that there's value in having more than one database from the perspective of being able to break up your mailboxes and putting them in different databases. That makes it easier to back up and restore those databases in the event you do have some type of disaster that hits, and let's say you need to now restore those databases from a backup. So that's one reason to have multiple databases. Another is from the perspective of performance and having those databases split across multiple drives that you might have in play. The other might be from a perspective of management of mailboxes or management of storage in terms of where you put those databases so that you can make sure you have enough storage space for each of the databases depending on how you're using Exchange. So there are plenty of good reasons to create additional databases. Each of those databases is an EDB file. Now, for years, folks have been wanting a change when it comes to Exchange over to SQL as the database instead of ESE. But in the words of Exchange team expert Ross Smith IV, SQL squeals like a pig where ESE is easy. Now, what did he mean by that? Well, my guess is that he means that ESE still outperforms SQL when it comes to the typical transactions that are performed against an Exchange database. So, with Exchange 2013, we haven't seen a switch to SQL as the database and the engine behind it. However, there has been some changes in terms of the architecture with regard to how the database is managed and how things work. Let's talk about some of these. So there are information store processes, Microsoft.exchange.store.service.exe and Microsoft.exchange.store.worker.exe, and these have been completely rewritten in C# to provide greater stability as well as to allow each database to run under its own process. So the value here is that each database now runs in its own dedicated worker process, which means the process of one database will not impact another process on another database in the event that process or database hangs. So that's certainly a benefit in terms of the way Exchange works. Now we call this newly rewritten information store process the managed store, which has fast search integrated into it with better search and indexing capabilities. You'll recall fast search is something that was purchased actually. The company was purchased by Microsoft and pulled into SharePoint with SharePoint 2010. And so now that fast capability when it comes to search and indexing has been pulled into other parts of the Microsoft world, and we appreciate that it's being pulled into the Exchange world. Okay, so we understand that there's a database. We get that. And we understand that there has to be processes working in the background in order to monitor and maintain that database and make sure that it's stable, make sure information can be written to it properly. There has to be a schema involved so that that database knows where to put data. All of that makes sense, right? But how does Exchange literally work in terms of taking an email into the Exchange server and putting it into that database. Let's take a look. When mail comes into the mailbox server, it first goes into memory, and then it gets written to transaction logs. Now these logs are 1 megabyte sized files. So if you have an email that overall is about 10 megabytes, you can see 10 or 11 transaction logs as the result. From the transaction logs, it is then written into the database, the EDB file, when that database is free. So if the database is busy and it's serving a lot of requests at that time, the write from transaction logs to database is held until that database is free to accept new data. Typically, this all happens very quickly. Now, if a failure were to occur, let's say the email has come in, it's gone through memory, it's been written to transaction logs, and let's say these logs have not been written into the database, and the system goes down. How does the system recover? Is that email lost? Well, there's a checkpoint file that helps to ensure all logs are written to the database. So when the server comes back up, the checkpoint file is looked into, and in the event there are any transaction logs that have not been committed to the database, those logs will then update the database, and this helps to keep the database up to date. Now, we're not going to discuss best practice at this time in great detail. However, it's good to note that it's recommended that you separate your transaction logs from your database on separate disks. And the reason for this is so that in the event there is a failure of the disk, you're not losing your database and your transaction logs. It's good to have those separated. At the same time, we'll also discuss in the future some best practice with regard to the performance and safety of your database. Now, all of this is perhaps theoretical to you. Perhaps you've never seen an EDB file or a transaction log. Let's change that. Let's jump over to our Exchange server and let's take a look at the default database that was created when we installed Exchange. And we'll take a look at both the database as well as the transaction logs. We'll see the checkpoint file, and so all of this will become a little bit clearer once you can actually put a face to it, so to speak, once you can see how all of this really works on the server side. Alright, so here we are back on our Windows Server 2012 system, which is running Exchange 2013. If we go back to our Exchange Admin Center and log in, we can see here by looking under Servers and clicking Databases that when we installed Exchange 2013, and this is not something that we did together, this is something that I did before the course itself, and that was just so that we had a functioning version of Exchange that I could use for these early lessons. Not to worry, we'll install Exchange together soon enough. But when I did the installation of Exchange 2013, there was a mailbox database that was created, and it gives it this long, crazy number to start with. And so it's just a way of generating mailbox databases automatically without human intervention. So fair enough, we have this database, it's there. You might want to create additional ones, you might want to change the name of this one. That's fine, that's something we can certainly do all through the tools that are provided by the Exchange Admin Center, and we'll focus on this in a future lesson. But really, what we want to do now is we want to go in and see the database file and the transaction logs. So basically, this is what we're looking at. Here, if you look through Program Files, Microsoft Exchange Server, v15, Mailbox, then you find the Mailbox database. In this case, if we go here, there's only one database, so it's easy to find. There's the long number at the end. And there we have it. Now, we have to scroll down to the bottom to find the database itself, but notice this. It's a single EDB file. It's the largest file in here. And as emails continue to come into your Exchange environment, this file will grow and grow and grow. And so it becomes the largest of files on your whole system, and it just keeps getting bigger. And that's one of the reasons why you need to make sure that you have plenty of space on your storage for your EDB file to grow. And at times you may want to create multiple databases, and so you'll have multiple EDB files. You can put these all on the same storage, or you can separate them out and put them on separate volumes. So as we look at this, you see all of these 1 megabyte files. These are the logs that are building up. Those are transaction logs. And you can see up here the E00, this is the current transaction log, and then all of the logs after that are logs that have been completed and sealed and saved over, so the logs continue to add up, but the current transaction log is always the E00 log. And then we have the checkpoint file here. At the same time, you see there are a variety of reserved logs. This is just to make sure that in the event the storage space does run out, that there is some extra space there. So hopefully this gives you a better idea in terms of how Exchange works, how mail flows from memory into transaction logs into the database. And so from this point, now that you have a good understanding as far as Exchange and the database side, let's jump back over to the slides and let's talk about Exchange server roles and how they've changed from what we had with Exchange 2007 and 2010 to what we have now with Exchange 2013. Okay, so before we go forward into a discussion of server roles with Exchange 2013, I thought it might be best for us to discuss the way server roles have been utilized in the past two legacy versions of Exchange, Exchange 2007 and 2010. Because once you see the 5 roles as they map out here, then you'll understand a little bit better how these roles have been merged down into 2 roles for Exchange 2013. So for starters, we have the mailbox role. That's the easiest one to explain, because even with Exchange 2007 and 2010, this role hosts your user mailboxes with mailbox databases. And the mailbox role also hosts public folders. So that's pretty much unchanged even as we go forward. The mailbox role still does that. Then there's the client access role, which is the connection point for all of your users to their mailboxes, both internally and externally. So the connections require either MAPI connectivity, Outlook Web App, Outlook Anywhere, ActiveSync, or IMAP and POP connectivity. Now the difference with Exchange 2013 you'll find is that one of these is missing. I won't give it away yet, but you'll find that one of these is missing with the new client access role. Then we have the hub transport role, which manages the flow of traffic to and from the mailbox server. Now this was an essential role because it was this role that manages things like transport rules and so forth. So as mail would come in or out of the organization, it would have to hit the hub transport server role. Or if there were multiple hub transport servers, it would hit one of those servers. So all mail went in and out of the organization through a hub transport server role of some sort. And that made it easier for IT admins to establish rules because mail would flow through a hub transport server at some point. The unified messaging role provided a universal inbox for voicemail, email, and incoming faxes. And the way that it did this is it took over for your existing voicemail services and pretty much took over that piece within your infrastructure for voicemail, within your call infrastructure. So you would still have your legacy PBX perhaps connected up to a voice over IP gateway, or you would have an IP PBX, and this would really be the backbone of your call system. But when it came to the point of leaving a voicemail, when a person, let's say, didn't answer their phone and a voicemail would be left, that would be transferred off to the unified messaging server, the voicemail would be left, and then it would go into a universal inbox. And then that message could be put right into a person's inbox. So there were a lot of great benefits to that, but we still didn't see UM deployed on a large scale, not with 2007, a little bit more with 2010, and now with 2013 you'll see that it gets merged in with the 2 roles that we have left. And then last we have the Edge Transport Server role. This provides a perimeter-based server that handles anti-spam and antivirus protection, as well as the ability to establish additional transport rules. Now, the Edge Transport Server role does not get merged into the 2 roles for Exchange 2013. So you might be wondering, well, what happens to the Edge Transport Server role? Well, not to worry, we'll get to that in a moment. But these are the 5 roles that were established with Exchange 2007. Now, the reason why these roles were originally broken up with Exchange 2007 is because processing power was significantly less than it is today. And so when it came to deploying Exchange, it made more sense to break up the various roles of Exchange so that you can put them on multiple servers. However, over time, as processing power increased and as Exchange tightened up a bit and could handle the load a little bit better with each release, with each service pack, as it got better and better, starting with Exchange 2010 Service Pack 1, Microsoft started to change its position and recommended building all Exchange 2010 servers as multi-role servers. And so the idea was that you would install a server with multiple roles, typically the mailbox server role, the client access role, and the hub transport role. The unified messaging server role would only be included on servers that really required that if you had a UM infrastructure in place. If you weren't using unified messaging, then you didn't have to install that piece in your Exchange environment. So the idea was to have multi-role servers because it just made sense to install all the roles on one box. Let's look at the way this would all play out in an organization. So in deploying Exchange 2007 or 2010, what you would do is on the internal network, you would deploy multiple roles either on one box or on multiple boxes, and these could run in a physical environment. You can run these server roles on the physical systems themselves, or you can virtualize all 4 of these server roles. Now that was not always the case. Microsoft did not always support virtualization of all of the server roles. For example, the unified messaging server role was not supported until Exchange 2010 with Service Pack 1 or 2. And so that role would not be able to be virtualized. But ultimately you would deploy these server roles either together, all 4 of them on one system, or separated out. And you would do that on the internal network, which means the server that you would deploy them on would be a member server connected up into your Active Directory domain. Now, on the perimeter network, also known as the DMZ, that's where you would place your edge transport server. And that server would be utilized for additional protection, antivirus, anti-spam, as well as additional transport rules. You might also deploy in the perimeter additional servers or services that would help to protect your internal network. Perhaps you utilize something like Forefront Threat Management Gateway or something up in the cloud or some other solution in play. So there were a lot of different options that you could utilize to ensure that you protected your internal network. But all of those things would run either in the perimeter, which would be separate, so the Edge Transport Server is not a member of your Active Directory domain, or it would be a service or solution that ran in the cloud. So that's the way things work in Exchange 2007 and Exchange 2010. How have things changed with Exchange 2013? The server roles for Exchange 2013 actually mimic the same roles that we had with Exchange 2003. Granted, the technology has changed greatly, the code has changed tremendously, the actual functionality of Exchange Server has changed, and the way we manage it, so many things have changed. But with Exchange 2003, we pretty much had a front-end server that handled client access coming in, and we had a mailbox server, which is the back-end server for handling databases and mailboxes. So with Exchange 2003, we see a return to basics. We have the mailbox server role, formerly known as the back-end server, and the client access role, formerly known as the front-end server. Now, even though we're using these terms, front-end and back-end, really we're still looking at it from the perspective of the modern set of server roles. How do the modern roles play out when it comes to merging them into these 2 roles that we see here? Well, let's first look a little bit deeper at the client access role and see what the client access role is designed to do in Exchange 2013. So for starters, the client access in 2013 proxies connections to the mailbox server. Now those connections might be from Microsoft Office Outlook, Outlook Web App, which is the browser-based flavor of Outlook, mobile devices that have active sync connectivity. So if you have an iPhone or an iPad or an Android device or a Windows phone, all of those mobile devices have active sync connectivity. POP or IMAP connectivity and SMTP connectivity, depending on the type of the email application that you're using. So all of these connections go through the client access server in order to connect to the mailbox server. So that's what the CAS role does. It enables clients to connect to Exchange. It performs authentication, redirection, and proxying while the mailbox role processes the request once the mailbox role gets that request. And the CAS server has two services, which we'll discuss in a moment. It has the client access service and the front-end transport service. So that client access service provides the authentication and the redirection, and it works as a proxy to that mailbox server. But the front-end transport service offers the protocol, connection, recipient, and sender filtering, and it also helps to determine which server is the proper active mailbox server for the request that's coming in. Now, one benefit to this change is that Layer 4 load balancers can be used to balance the traffic between CAS servers grouped together in an array. Now, why is that important to note? Well, if you're establishing larger organizations, if we did it with Exchange 2010 or 2007, we would have to make sure that our load balancer allowed for Layer 7 load balancing, and so this was a little bit more expensive. And so now we can work with lower level, cheaper, we should say, devices that can load balance that traffic. So that's just an added benefit to the change up in the architecture, going to the client access server handling all of that traffic in that way. So that's just one of the benefits to adjusting the architecture to a two server role environment with the client access server handling connections in this way. Now, we mentioned that there are two services, the client access service and the front-end transport service. So if we look at the client access service, this provides the unified namespace, the authentication, and the security. It routes requests to the right mailbox server. It proxies or redirects requests for legacy servers as well. So when you're in the middle of a migration and you might have additional servers in the mix, let's say you have Exchange 2007 or Exchange 2010 mailbox servers that you still have in your environment, the client access service is what helps the client access server to redirect that request toward legacy servers. At the same time, we have the front-end transport service, which provides, as we said a moment ago,